Welcome everyone to the latest Trees Around the Globe Student Research Campaign webinar. This is the last campaign webinar for year 7, and this is the State of Trees, September 2025. Looking back at 7 years of the Trees Around the Globe Student Research Campaign, what we've done and what is to come. And I don't have this on here, but we have a featured presentation that ties into what we did at last month's webinar. We have Dr. Erika Podest, who will be talking about the NISAR mission today. We gave a little teaser at the end of last month's webinar about the NISAR mission. And as you may remember, last November at the second campaign webinar for year 7, we had Erika talking a little bit about NISAR and some wetland science that she's working on with her research. She'll be talking more about NISAR today, but stay tuned for that. It's going to happen right after I talk about some of my introductory information here. So I wanted to start off a little bit with some quotes, as I always do, to get us inspired for today's webinar. First one is from Carl Sagan. You may have heard of him. He is an American astronomer, was an American astronomer and planetary scientist, science communicator, and author. Said, somewhere something incredible is waiting to be known. Just think that's a nice overarching quote. And then we have one from Mae Jemison. She is currently an engineer and a physician and a former NASA astronaut. She said, don't let anyone rob you of your imagination, your creativity, or your curiosity. It's your place in the world. It's your life. Go on and do all you can with it and make it the life you want to live. So I'm not going to say little, great quotes of inspiration here to get us, started on this campaign webinar. Once again, the final webinar for year 7 of the Trees Around the Globe Student Research Campaign. And as I mentioned, we have a great presentation in store from Dr. Erika Podest, and I won't go through all of that because we're going to have our own Peter Falcon introduce Dr. Podest in a minute or two. And then we're going to do a little bit of recap. We're going to review, and this was something that has been a request of some folks over the last couple months. I'm going to go over the, some of the NASA Moon Trees program stuff, just a little recap, a couple minutes there. And I'm going to quickly go over the 7 years poster in a couple minutes. And then I'm going to show a couple highlights from some of the student presentations that we've had over the last few years. There's going to be some clips I'm going to show that I pulled out of some of the webinars over the last few years that I know a lot of some folks enjoyed, and they requested to see some of them again. Those are from some from the Globe community across the world. And then I'm going to highlight some of these missions that we've been talking about over the life of the campaign, just some short clips from some of these missions. And then we hope to get some campaign participants here, you folks that are here at the webinar, to give some reflections of what you've seen over the last 7 years, and then a little bit what's to come year 8. And then we'll finish the webinar. So let's get started. Okay, here's our map that I always like to show. We have participants, active participants in the campaign from 70 of the 127 Globe countries. And these are ones that are actively participating in the webinars, collecting the data, that are submitting campaign-related IVSS projects, presenting at our webinars, having teachers involved as well. Here is the data that's coming in for the tree height, land cover, and greetings from the beginning of the campaign on the 15th of September 2018, all the way through. Actually, I did the review of the data today and got the data counts today. So this bottom one, year 7, so October 1, 2024 through today, you can see we have just over 39,250 observations from over 11,400 global sites. But I want to direct you here for the life of the campaign. We just topped the 250,000 observation mark from almost 76,000 global sites looking at the tree height, land cover, and green up, green down, or greening observations. And as you know, we have a lot of blogs that are part of the campaign, and also I include ones that are campaign and trees related that either I've written or other folks have written that are trees and land cover related that are part of the GLOBE program's Globe Observer project, because we write those and they tie back to our campaign. And then you can see here, we are in the 85th webinar, but we've had 33 special campaign webinars, ones that we've given to different regions as part of our campaign. So we have lots and lots of momentum going here with the campaign. So, stay with us. All right, so last thing I want to show you before we have our featured presentation from Dr. Erika Podest is if you were part of the virtual GLOBE annual meeting in July of this year, you probably saw this, but I just wanted to highlight this again since we are looking, we are on the final webinar for the 7th year. This is a poster that we put together for 7 years of the Trees Around the Globe Student Research Campaign. And this is a synopsis of those 7 years of all the amounts of webinars we've had, how many webinar participants we've had, where the data is coming from. On the bottom, that's just I just took some random screenshots of some of the presentations, some of the student research projects from the presentations that were presented for IVSS over the last 7 years from some of the different countries that are part of the campaign. You can see we have Ecuador, the US, Thailand, Brazil, Saudi Arabia, Ghana, and Croatia. And that is not an exhaustive list. They're from all over. So, all the way from all of the 6 different globe regions across the globe community. These are just ones that I grabbed. And each year, if you've seen, I've done posters from year 1 all the way through year 7, and I include these, but we've had a lot of, we've had lots and lots of IVS. We've had over 150 IVSS affiliated projects with the campaign over the last 7 years. So, and each year, the amount of the amount of IVSS projects that we get related to our campaign grows every year. So that's really, really great to see. But this poster, it's great. We have it on our campaign website, so it's up there. So you can go onto our campaign website on the Globe page and check it out. So we have it up there. But you can learn all about this campaign and look how this synopsis goes. And over here on the right, you see those 6 boxes there. Those are just showing you some of the past shareables that we have that you see every month that come out for the webinars. But the little trees also that you see are just some breakdown of the amounts of webinars, the countries participating, the number of countries, and then all the way through the IVSS, the number of scientists that we've had involved in presenting and, looking at the data, and then, some of the IOPs that we have as part of the campaign, the intensive observation periods. All right. So we have our featured presentation. I have this listed as featured presentation 3 because as it's a continuation from last month's webinar where we had Dr. Felix present, and then we had our own Peter Nelson present, and now we have Dr. Erika Podest present, and I will pass it over to Peter Falcon to introduce our speaker today.
Yeah, thanks, Brian. As he asked me to do this just a minute ago, and I'm thinking all of my thoughts about Erika and how many years I've worked with her. I've known her for so many years. I think I started working with her during the QuickScat era, and since then, she's worked on so many different missions. You've probably recognized her in many of our webinars before. She's a great friend of the Globe program and our Globe community, always specifically working with Latin America. She's amazing with our Latin American groups. She's worked on, as I mentioned, QuickScat, SMAP. She's part of the RSAT team as well, and now NISAR. So she's been a part of JPL for many years, part of many missions, and it's always a pleasure to work with her. I'll just read through her bio very quickly, which is probably out of date from all the things that she's done in her career at JPL. But she is part of the Carbon Cycle and Ecosystems group here at JPL, and she also specializes in effects of climate change on terrestrial ecosystems, particularly with wetlands, which I believe she's probably going to be talking to us about today. And she also is interested in integrating different remote sensing and in situ measurements that address biodiversity. So with that, Erika, as always, thank you for being a part of these webinars. Thank you for being a part of the Globe community for so many years and always being there when I need you, when people like Anna and others request you. So I just want to say thank you very much for all the work you've done for us in the past, and you continue to as well for the GLOBE program. So with that, I'm going to turn it over to you, Erica, and once again say thank you.
Thank you very much for that really kind introduction, Peter. It's great to be here. It's been great to be part of GLOBE and see it evolve and see it grow. And I'm excited about this new mission called NISAR and its connections to GLOBE. So let me share my screen. How much time do I have, just to confirm?
As long as you need, 15, 20 minutes, however you like. Just there's and some Q&A at the end. Peter will lead then.
Great.
Yep.
Okay, so what I wanted to give you is an overview of NISAR, which is NASA's latest Earth observing satellite mission, and what it's doing and its connections to GLOBE, right? So first of all, NASA is a satellite mission, a joint satellite mission between NASA and the Indian Space Research Organization, which is called ISRO. It's a satellite that contains a radar sensors. Actually, it contains two radar sensors. One operates at L band and the other one operates at S band. And I'll talk a little bit about that. The satellite, it has a temporal repeat, so it flies over the same spot on the Earth every 12 days. So the satellite has global coverage, covering the same area every 12 days. And there's many things that NISAR will be able to do. It just launched, by the way, on the 30th of July of this year in 2025. So over a month ago, and it launched from India. It was a picture perfect launch. I was there to see it, and it was a very exciting moment to be able to see how these missions come together and to see these concepts that are on paper and how the scientists work with the engineers to really come up with a design that will fulfill the science needs. So this is a whole process. Putting satellites in space is really a complex process where things are justified by the science need, right? So we need this sort of data for many different things: to monitor water resources, to monitor the ice on Earth, to monitor land cover. And so that's the science need. And we also define as scientists, what are the specs behind that need? So there's the need, but we need this data every so often with a certain degree of detail, right? So once you define the justification and the needs, the characteristics, then we work with the engineers for them to actually design a sensor that will meet those characteristics. So it's a process, right? So scientists are the dreamers, and the engineers are the ones that make those dreams possible. And so it's a extensive process, but it's a beautiful process, say, once consensus is reached that, hey, we can do this within a given budget, right? Because that also defines the limitations of what can be done. All right, so NISAR does many different things. It's observing our planet with radar data, and you can look at ecosystems, you can look at land cover, you can look at biomass change, you can look at the dynamics of ice sheets, glaciers, and how that's affecting sea level. So how fast are glaciers being lost, and what are the implications of that glacier loss, which is really ice that goes back into the ocean in the form of ice. It eventually melts as water. And so that has an influence in the increase in sea level. So how do melting glaciers and ice sheets, what is the implication of that in terms of increasing sea level on our planet? There's surface deformation. So one of the things that NISAR can do is it can measure very small changes in the surface of the planet, surface displacement. That means if there's on the surface, if there's a change in the surface, it can measure that change on the order of centimeters. And whenever an earthquake occurs, for example, you've got these shifts in the plates, right? And you can look at what those shifts are from space, whether it's on the order of centimeters or even meters, right? And then you can have an assessment of the impact of the earthquake in this case. There are also coastal processes looking at coastlines, mangroves, bathymetry, and other applications that have societal impacts. So you can use the data for looking at flooding, agricultural monitoring, identifying hazards for urgent response and hazard mitigation. Okay, so this is just a quick overview of the characteristics of NISAR. Again, it operates at two different frequencies in the microwave range, L-band and S-band. And it also has this capability called INSAR, which is interferometric synthetic aperture radar, where you're looking at the difference in phase over two different observations. How does the phase of the signal change? And how is that phase then related to changes in the surface that are around a couple of centimeters? I'll show some examples. Now, that's an overview of NISAR, right? Now, what I want to do is I want to talk a little bit about radar. So for those of you that are not so familiar with radar remote sensing, it can give you a little bit of background about the benefits and why we're putting a radar sensor in space. And you've got the whole electromagnetic spectrum, and you've got different parts of the electromagnetic spectrum. What we're most familiar with is the visible part of the spectrum, which is really a small sliver of the electromagnetic spectrum. Really, what we can see around us is just a very small portion of all the energy that is around us. Most of the stuff we can't see. And for example, if you look at Google Earth or Google Earth Engine, the images that you're seeing there are visible images, right? So it's what you would normally see with your eyes. And it's easy to relate those images because it's what you see with your eyes, and grass is green and the deserts are brown. So it's all relatable. The problem with visible is that whenever there are clouds, you can't see the surface. So it's hard to monitor certain areas of the planet whenever there are clouds. And some areas, like the tropical rainforest, are constantly covered by clouds. The advantage of microwave, which operates at a different part of the spectrum at a different frequency, is that microwave can see through clouds. So it's a great benefit in that we can now have the ability of studying our planet regardless of whether there are clouds or whether it's day or night. So it's an active system. And here I'll touch on, they're generally in space, we have two different types of sensors, passive sensors and active sensors. Passive sensors, again, optical, it's like a camera. So you're basically detecting the light that's emitted or reflected from another source, and this is light from the sun, right? And then active sensors, it's like having a flash on your camera. You're basically providing your own source of illumination. And in this case, with active sensors, you send a signal, and that signal interacts with the surface and is reflected back toward the sensor. And that sensor collects that reflected signal and creates these images that are called radar images, which are analogous to ultrasounds. Okay, so examples of active sensors are sonar, LiDAR, and radar. And that's why active sensors are that operate, at least in the microwave range, are not sensitive to clouds, because you're sending your own source of illumination, and that signal penetrates clouds. Okay, so I touched on this already, but the advantages of radar over optical: near all-weather capability, day or night capability. The signal can also penetrate, the radar signal can penetrate through the vegetation canopy. And this is something that optical cannot do. when you have an optical image, say you go to Google Earth and you look at a forest, what you're looking at is the top part of the canopy of the forest, right? That signal is not penetrating through the forest to give you information about what's underneath the canopy. And then there's the minimal atmospheric effects. So with optical, the atmosphere, you need to account for the atmosphere. So sometimes the atmosphere has a lot of water vapor and that affects the signal. And so you need to basically tease out the atmosphere to understand the true nature of the signal that you're receiving. And so the bottom line is that optical images are sensitive to the chemical properties of the land surface, and radar images are sensitive to structure and motion and moisture. And this is just an example of, the areas that are cloud covered on the planet. And so the areas that are like light blue, whitish, are areas that are more cloud covered than the areas that are dark blue. So if you look at like the Sahara, there's not that much cloud cover there. But if you look at the tropics, the Amazon, for example, or the Congo Basin, there's a lot of cloud cover. So this is the average cloud cover from a period of 2002 to 2015. This just gives you an idea of how prevalent cloud cover is in many parts of the world and how beneficial radar is really to studying these areas, as well as the northern high latitudes, which are under darkness, or the high latitudes, not only the northern, but the southern, which are in darkness for a large part of the year. So you can still image and monitor these areas regardless of whether it's day or night. Just a little bit of technical stuff about radar. So radar is a sensor that looks sideways and it sends the signal. The signal then reflects from different surfaces and returns back to the sensor. Part of it returns back to the sensor. And then you can separate the objects on the ground, right? And so the signal will be reflected back toward the satellite depending on the characteristics of the surface. And so you've got what we call different types of backscattering mechanisms on the surface. You might have a smooth surface. So since the radar is side looking, right, as here, and say you have a body of water, a calm body of water, what happens is the signal is going to reflect away from the satellite and bodies of water are going to look dark. However, if you have some sort of roughness, say it's the same body of water, but there are lots of waves, right? Then there's going to be scattering of that signal in different directions, and some of that signal is going to be returned to the satellite. Then you've got something called double bounce, and this is where you have a smooth surface followed by something very geometric. It could be a building in urban areas, or it could be, say, a flooded forest where you've got standing water underneath. And then you've got the tree trunks, which are these vertical surfaces. So the signal goes in through the canopy, bounces off the smooth water, and reflects away from the satellite, but you've got the tree trunks which then redirect that energy back toward the satellite. And then finally, the last backscattering mechanism is called volumetric, and that's where you have a volume like a forest, for example, where you've got trees, not only trees, but they're comprised of branches, leaves, needles, twigs, trunk. And so that signal goes into that volume and it scatters off of different components within the volume. Okay, and this is just an example of volume scattering. You can have the signal scatter directly from the tree trunks. You can have the signal scatter from the ground, crown scattering, crown ground, ground trunk. So there are multiple different combinations of where that signal can scatter. So this is just an example to give you an idea how to visualize radar images. And I mentioned the different scattering mechanisms. So when you have a really smooth surface, like a body of water, then the signal scatters away. And what you're seeing here in this image, this is a radar image. It's an L-band radar image from SMAP. And this is the Amazon basin. Now, the really dark areas, this is the Amazon River. And so again, the Amazon River, it's a smooth surface of water, and it's black because you've got a smooth surface where the signal is scattering away from the satellite. In this case, you've got some sort of low vegetation. It could be a tilled field, or it could be a deforested area. And so it's not completely smooth as a body of water. It's got some level of roughness. And so that will cause some scattering. And part of that scattering will reach the satellite. And so the brightness of the pixel is going to be not super dark, but it's going to be a low gray. And then you've got forest. So that's volume scattering. Again, that signal goes in there, scatters from different components within the vegetation. And then part of that signal is returned back to the satellite. So over forest, you see a brighter pixel. And finally, you've got what's called double bounce. Again, you've got the signal penetrating through the canopy. It reaches the surface of the water, which is smooth. And so it bounces away from the satellites. But you've got all of these tree trunks which redirect that energy back toward the satellite. So there's a very strong return. There's a large part of that signal is returned back to the satellite. And that's why inundated areas, in this case, inundated vegetation, appears very bright. So radar is really a superb sensor to study wetlands because of that capability to penetrate the canopy. And this is the Amazon basin during the high flood season. And you can see just tremendous flooding going on in this area. All of these white areas, all of that is flooded. This is flooded vegetation. Some are small tributaries. And these are things that you cannot see with optical data. Okay, so now let me kind of take a little bit of a deeper dive in terms of what NISAR is observing in terms of vegetation, which is related to some of the Globe Observer apps, right? So land cover and vegetation height. So what NISAR, one of the things that NISAR is observing are wetlands. And really what we're trying to determine is not only the extent of global wetlands, including the timing, frequency, and duration of both saturation and inundation. And so what we want to do is we want to reduce the uncertainty in how much wetlands contribute to methane emissions, because wetlands produce methane. They produce a large amount of methane, actually. Over time, they tend to be more of a storage of carbon rather than a source of carbon. However, the concern is with our changing climate, increasing temperature, less precipitation, how will these important ecosystems change from being net sinks of carbon to net sources of carbon? And that's where NISAR is very useful in being able to monitor the inundation extent and dynamics of these ecosystems on a global basis, and how that is changing from year to year. And what are the implications then in terms of methane emissions? So this is just a little bit of background about the importance of wetland ecosystems. And they cover just a very small portion of the surface, the Earth's surface, 7%, but they really account for a large, disproportionate share of the carbon pool, right? And wetlands have many other benefits. They're sources of water and of food, biodiversity, income. But from a carbon perspective, the water stored in wetlands is an important component for terrestrial carbon storage and plays a very large role in the emission of global atmospheric methane. And this is just to give you an example of when we're talking about methane, how there are different sources and sinks of methane. Some are anthropogenic, fossil fuel production and use, agriculture and waste. So these are anthropogenic, biomass and biofuel, but there are natural sources of methane, sources and sinks, right? So wetlands is one, and you got other natural emissions and chemical reactions in the atmosphere. So you got, and soils, but the natural source that on land that has the largest uncertainty are really our wetlands. And so that's why NISAR is really so important in being able to monitor these ecosystems and reduce the uncertainty in our understanding of wetlands, how they're changing, and what are the implications. So this is an example of what we can do with radar imagery. Again, I showed you that previous example where you saw that wetland ecosystems, when they inundate, they appear very bright, right? So with time series data, L-band imagery, here in this example, we can see the same area in the low flood season and then in the high flood season. And you can see all of the white, that's all inundated vegetation. So you can see how dynamic this area is throughout this period of time. So it goes from pretty dry to super inundated. Okay, so now let's move on to NISAR and trees. Again, so NISAR will be very beneficial, very useful in monitoring land cover and monitoring trees, vegetation biomass, how that's changing through time, and also identifying areas where there's deforestation and forest degradation. And the ultimate question is, how will forests react to global warming, and will they become greater sources or sinks of carbon? Right, so trees, in terms of carbon, they play a huge role. They're the lungs of our planet, right? So trees take up CO2 from the atmosphere. They store it in their biomass, right? And then they do tend, and they're also stored in the soil through roots. And so trees tend to have the cycle, they grow, they absorb a lot of CO2, then that kind of flattens out as the tree reaches certain maturity. Obviously, it depends on the tree. And eventually the tree dies, it goes back to the ground, it decomposes, that carbon is released in part to the atmosphere. Some of it is stored in the soil. Okay, and so this is just an animation of showing the role of the vegetation in the uptake of CO2 globally. And so what we're seeing here on land, whatever you see green, that's the greening of vegetation. It's usually cyclical, especially in the northern high latitudes where you have these marked seasonality, where, in the winter, the trees go dormant. You've got deciduous trees that lose their leaves. You've got evergreen trees that they just basically hibernate. So there's no or minimal exchange of gases between the vegetation and the atmosphere when things are frozen in the northern high latitudes. However, when spring comes around and you've got the thaw, then it's like a switch. The growing season, the vegetation growing season begins, and there's a huge uptake of CO2 from the atmosphere from the vegetation. And this is driven primarily from the vegetation in the northern high latitudes. If you've ever seen the Keeling curve, there's a season, not like a yearly seasonality, right? Where the atmospheric CO2 concentrations, they kind of reach a peak and then they go low and they reach a peak. So that is driven by the growing season length in the northern high latitudes, that period of time when the vegetation breathes in CO2, and so it reduces the global atmospheric CO2 concentrations. So that's kind of what I want to show you, our Earth breathing through this video. And the green areas, again, these are areas that where you've got vegetation growth or green vegetation that's active. And then what you see in the yellow, that's atmospheric CO2 concentration. So you can see in the winter, this is all white, the atmospheric CO2 concentrations around the planet increase, and then you've got the growing season length, everything greens up in the northern high latitudes, and that atmospheric CO2 concentration drops, right? So this is a yearly cycle, which is amazing. Like, this is really watching our planet breathe. So it's important to monitor vegetation from space, because we've got global vegetation, we've got some really remote areas that, where you have a lot of vegetation, that these areas are very hard to access. And so one of the things that NISAR is going to be doing is it's going to be looking, or you can have the capability of looking at biomass with NISAR, right? So what is the biomass of the vegetation, and how is that changing from year to year? And what are the implications of that? And so biomass can be changing because of stressors. It could be changing because of drought, right? So vegetation naturally thins. There could be logging, like forest degradation or deforestation. So you've got a loss of biomass. You can have insect infestations that kill off trees, and you have a loss of biomass. So, so this is a capability that will be available with NISAR in terms of assessing global biomass. Now, something else that we'll be able to do with NISAR is to look at forest degradation. And this is something that sometimes it's tricky, because forest degradation can be a result of different things. It could be, again, a bark beetle infestation, so you've got a degraded forest, or you can have selective logging, for example. And so these things are not always visible with optical imagery, but with radar, since that signal penetrates through the canopy, then, and it's sensitive to structure, you can see these degraded areas. And this is something that we're seeing here in these, in this area. You've got these zoomed in areas where you've got deforestation going on, you've got forest degradation, and then you've got riparian forest. Another thing that we can do in terms of looking at vegetation with NISAR is looking at the global crop area, which is super important for agriculture, for feeding our planet. And because of the resolution of NISAR, so what the resolution is going to vary on the scanning mode, but we're looking at imagery anywhere from 10 to 20, 30 meters spatial resolution. And we'll be looking at, NISAR will have the capability to look at areas where there's agriculture and identify some basic characteristics of agriculture, whether the fields are active or inactive, which is super important. And you can also monitor vegetation or crop growth through time, which is an important variable, especially in crop models where you want to assess the crop productivity at the end of a season. All right, so this is another example. This is the phase example where I told you we can measure like small changes in the surface, so small displacements in the surface of the Earth, right? And so what we're looking at here is the Los Angeles Basin Aquifer. And these aquifers, they have a natural cycle, right? So in the dry season, water is drawn from these aquifers, so they kind of dry up. But in the wet season, they are recharged by rainwater. And so you've got this drying and then filling. And what happens when, you've got these aquifers filling up and drying up is that there's a small displacement in the surface on the order of just centimeters that you can actually see from space. It's really amazing. And it's like, say you overeat something, if you've ever overeaten and like your belly pops up a little bit because you're just so full. So that's what happens, right? When these aquifers are filled, the surface rises a little bit. And then when they're empty, it goes down a little bit, a couple of centimeters, and we can see that. And that's what this video animation shows. This is over Los Angeles Basin, but you can see the seasonal cycle of the aquifers within the Los Angeles Basin going up and down. And so whatever is on the bluish side is -15, -30 meters displacement, and then, or going down, and then what's in red and white, it's going up. So it's pretty cool what you can do. And this is in Los Angeles Basin, but if you look at places, say, heavy agricultural areas, for example, the Central Valley of California, where there's a ton of agriculture and there's a lot of groundwater withdrawal, you can see the groundwater withdrawal and whether the aquifers are given enough time to replenish that withdrawal. Okay, so how are we doing on time? All right, so one of the things that is part of all of this work with NISAR, NISAR is making observations from space, but an important part of these observations is that we make all of these observations available on a NASA Data Archive Center. So anyone that's interested can actually use this data. But one of the things we do is we do a calibration and validation. We want to make sure that the data that we make available to the general public has a certain quality. And so we need to go into the field and install sensors that we can then compare the data that those sensors are providing with the satellite. For example, these pictures that you see here, this is in a tropical wetland ecosystem in Peru. This is a trip from a couple years ago where we looked at wetlands. And we installed sensors in these wetland ecosystems. At the time that we visited, it was low water. So this system here, it's a natural reserve called Pacaya Samaria. It inundates about, I think it's, a couple of meters a year during the high flood season. And you can see the waterline mark here in these red rectangles. You can see that transition between dark and white. That was the watermark for the last season. In some places, it could be some centimeters. In other places, it could be 5, 6, 7 meters. So it's significant. And so what we did here was we went in, we installed sensors that tell us how much water there is above the water surface. And now that NISAR is in orbit, we compare the data that NISAR is providing over these areas. And if they match, so the sensors on the ground, which we consider the reference data or the truth data, if they match with what the satellite is indicating, then it gives us confidence that the satellite is making adequate or accurate measurements over these areas. If they don't match, if the ground data is saying, hey, this is inundated, and the satellite is saying, no, I'm not seeing any inundation there, then we go back and we revisit the algorithm or the data itself to determine what are the issues and why are we not seeing inundation. Okay, so that gives you kind of an overview of the type of things that NISAR does. It does many other things. It can be used for flooding. It can be used it will be used to detect soil moisture globally. Again, above ground biomass. things like sea ice extent, ice and ship tracking, oil spill, volcanic eruptions, tornado damage, hurricane winds, looking at levees. So there's many different things that this data will be applicable to. And how is this related to land cover? Obviously, I mean, one of them is looking at land cover, looking at forest degradation, looking at what sort of vegetation is there, as well as wetlands, what sort of wetlands are there? Are they inundated or are they not? So the Globe app, land cover app, is actually a very useful tool to provide us data that is reference data that we can use then to compare that data with what the satellite is indicating. And there's globe trees as well, where you measure the heights. We do have we're looking at biomass. And so having information on vegetation height, carbon stock, or biomass, then helps us validate the satellite data. And in addition to that, we're adding other protocols into the Globe Observer app that are also directly related to NISAR. And one of them is an agricultural app that where you will be able to take pictures of agricultural fields to indicate if the field is active or inactive. And if it's active, to identify what sort of crop is being grown there, and taking pictures on perhaps what is the maturity of the crop, how high is it? Is it a cornfield, like a fully mature cornfield that's 2 meters high, or what is there and at what stage? All right. So with that, I really want to thank you. I hope this has been informative. This is a picture of our team when we went to work in the wetland complex in Peru, in Pacaya, Samaria. It was a great team. None of these things happen by one person. I mean, it takes a whole team, it takes a whole village, really, to make a satellite mission possible, and it has many, many different components. So every team, every person really contributes a very important grain of salt toward the larger picture. And that's what's so beautiful about being part of a satellite mission like this. And even better, is to involve citizen scientists and having them contribute toward the value of this mission. So thank you very much, and I'm open to your questions.
Thanks, Erika. As always, great presentation. We do have some questions for you. Funny, because I always heard of NISAR being referred to as the Swiss Army knife of satellites. And after the slide you showed all the things it can do, now I really see why they call it that. We have a question from Anna. She asks, are there any images from this satellite freely accessible? And when is the estimated time that we can use them?
Yeah, that's a super great question. And hello, Anna. So the images, right now we're in the commissioning phase. So we launched July 30th, and we go through this phase where we're checking out all of the instruments, all of the electronics. There's a large antenna that has recently been opened and deployed, and we've already collected our first images. They're not calibrated, and this image there's going to be a press release hopefully later this week showing these first images. Again, I believe we will be opening the images, the non-calibrated images, perhaps in the next couple of weeks, 2 or 3 weeks. They're not for science use, but they're for the community to start looking at them and even provide feedback about what are the issues. But the actual, like what we call the science phase, where it's now a routine, we're in our final observation orbit, and we're now doing routine collections, and the data have been calibrated, validated. That's about 5 months away. And they will be available through the Alaska Satellite Facility Data Archive Center. However, there's also going to be, I'm supporting a lot of trainings. There's going to be some video tutorials on the NISAR webpage on what the NISAR mission is about, what the different data sets are, what you can do with the data sets, with the different data sets. And I'm also supporting a number of RSET trainings on the applications of these different data sets. So how can you use NISAR data, for example, for looking at water resource management, like flood monitoring, looking at groundwater extraction, how to use NISAR data to look at disasters, earthquakes, volcanoes, landslides. So
That is a lot.
Yeah.
And we also put the NISAR website in the chat, and I know you put the QR code in your presentation as well to go to the website. So I encourage people to go there, check that out. And I also has a follow-up question. She says, besides land cover and clouds, any other globe measurements would be useful to have on the ground to help NISAR?
Yeah, so that's another great question. We've been brainstorming on that because there's great interest, obviously, in making a direct connection between globe measurements and NISAR. The easiest one is agriculture because it can be easily implemented in the Globe Observer app, and you just take pictures, right? There's the wetland one, which is a little trickier, and we're still trying to figure out how to best do that one so that people don't get stuck in the mud, for example. So they might have to take pictures from a distance. And so that's something we're considering. I know there's been recently a mangrove protocol developed in Latin America. And so we might be able to take that and maybe add a component that can be useful for NISAR. And then the other one that we're looking at is the forest degradation one. That might be an easier one in the sense that, you go to a forest and you can identify whether there's been like some sort of selective logging, or if there's, again, some sort of infestation, or there's stress in the forest because of, say, a drought. So that might be easier. I think that's the second one that we'll be implementing with Globe.
Thanks. And you hit on something that you talked about earlier, deforestation. My question is, what's the difference between deforestation and degradation, as you mentioned earlier?
Yeah. Wow, these are all great questions. So deforestation is when you lose completely the trees, right? So you had forest and they've been cut down. Degradation is you still have trees there, but they don't have the same level of biomass or health that they would normally have because there's been selective logging, right? So you don't have the same number of density of trees. You have 30–40% of the trees might be missing, right? So that's a degraded forest. Or when you have like an insect infestation, they might kill off a percentage of the trees, but not all. So you still have a standing forest, but it's degraded.
Gotcha. Thank you.
That's what we're calling degradation. Yeah.
Gotcha. And then in terms of wetlands, Anne has another question. She asked, would it allow, let me read it. It would allow us to measure changes in water bodies. When you're talking about water bodies, what about small rivers? Can NISAR help make measurements with small rivers?
Yeah, so the spatial resolution, depending on the acquisition mode, is going to be on the order of 10 to 20 meters. So potentially it can be used to look at changes in small rivers. I think that's a little bit exploratory to then understand how small rivers and what is the bathymetry of the river too, right? So if it's got, these steep slopes where a little bit of change in water will cause these exposure in the slopes, large exposures, then we might be able to see that. But if it's a deep river it doesn't have such steep slopes, you might not be able to see the large change that is occurring in the river. However, one thing that you can easily monitor with radar is the geomorphology of the river. And one of the things that we've seen, like in the Amazon, for example, is that the rivers are super dynamic and they change course even from year to year. So that's something that we'll be able to do. Now, but in terms of water level, in the small rivers, SWOT might be more suited for that. NISAR is not really going to give you information in water level change.
Gotcha. Okay, thanks. Another question from Marcus. He asked, in one of your slides, I don't recall which one, what are the yellow areas in the animation of the vegetation cycle of our planet? And I don't remember which slide that was.
Let me go back and take a look at my slides, and let me just share it.
If it helps, he commented about 6 minutes ago, Eric, so it's probably towards the end of your presentation.
Which ones? This.
Marcus, if you need to unmute and let Erika know.
Yeah.
Slide 22.
Slide 22, Marcus says.
Okay, so the yellow is atmospheric CO2 concentration. So that's what's in the atmosphere. And the green is what's on land. It's the vegetation on land. Right. So what you're seeing is, as you have an increase in the yellow, which is atmospheric CO2 concentrations, it increases when the vegetation in the northern high latitudes is frozen, right? And then it starts decreasing with that green up. There's a lag, obviously, but that's what you're seeing there. Right, so things freeze up. And then there's an increase in atmospheric CO2 concentrations. And then when things green up, there's a huge uptake of CO2 from the atmosphere. And there's a reduction in atmospheric CO2 concentrations. Yeah, with that. Okay.
And then Anna, she has one more comment. She says, I suppose regarding your training, first off, thank you for letting everyone know that's accessible to them. So she says it's very interesting to learn how to measure volumes and heights. So she's interested in your training. So thank you for mentioning that to us. One last question. I don't see any more questions in the chat, but one thing I know, the reason why we have you today is because you recently came from a field, working out in the field. Can you tell us a little bit about that and how that relates to NISAR and the work that you're doing? And I think a lot of students who are interested in science don't realize you don't just sit in front of your computer, coding and doing stuff, but you actually get up and you go out into the field and do, just different stuff. Can you just let us know about that and that experience?
Yeah, sure. Can I share with you a little video?
Of course. Yeah.
Let me see. Let me share with you. Can you see it?
Yes.
All right.
For greenhouse gas.
Can you hear it?
Yes.
When wetlands flood, they produce methane, which is a powerful greenhouse gas. In fact, wetlands are the largest natural source of methane on our planet. Knowing the extent and duration of flooded wetlands allows us to better estimate a wetland's methane production, which helps better understand how climate change is having an impact on wetland ecosystems. I recently returned from a scientific field campaign in the Peruvian Amazon. We went to Pacaya, Samaria to install sensors that measure when wetlands are inundated or flooded. These measurements will be compared to what the NISAR satellite will be measuring from space. If they match, then it gives us confidence that the satellite is making adequate and accurate measurements. If all goes according to plan, NISAR will be able to detect and monitor inundated wetlands from space, providing data similar to our ground measurements all year round. So what is NISAR? NISAR is a collaboration between NASA and the Indian Space Research Organization. The satellite will have 2 radars, allowing us to see the surface of the Earth regardless of clouds or day or night conditions. In this campaign, we focused on NISAR's ability to see through the canopy to detect different types of inundated wetlands. And given the dense tree canopy in the tropics, this area will be a test of NISAR's radar to detect inundation through thick vegetation. Our amazing team worked very hard and accomplished our goals for this field campaign. It was hot, it was hard work, it was difficult to access, but it was very productive. We installed over 75 sensors, which are up and running and ready for when NISAR overflies the area. I think this mission is going to be game-changing in our ability to monitor global wetland ecosystems. And that, my friends, will allow us to better understand our planet.
What a perfect plug. My question was to your video. And that video is available on the NISAR website, I imagine.
Yeah, so let me take a look. I can share it on the. Yeah, I'll share it on the chat.
Perfect. Thank you so much. I don't see any more questions. So with that, I think I'm going to turn it over back to Brian. But once again, like I said, always thank you for being here with us, for us. You mean a lot to the Globe community, and I know because I get a lot of questions, and I know I lean on you quite heavily, and you're always there for me, and you're always there for the folks that ask those questions and need you. So thanks a lot for all you do for us.
Oh, thank you. And thank you, Peter, for bringing me closer to the community.
My pleasure. All right, Brian, I turn it over to you.
All right. Thank you, Peter. And thank you again so much, Erika. And I can't say anything more than what Peter said, because you're just a amazing asset to NASA JPL and the Globe community. So thanks again. You've been a great proponent for everything we've done with the trees around the Globe Student Research Campaign, with Globe, and with our SMAP campaign and our ENSO campaign, and all the campaigns that we've done for so many years. We're in year 7 now. This campaign, we had the SMAP campaign. I think that was 1 year, and ENSO was 3 years between the SMAP and this campaign. So, and some of our participants that are on right now have been part of those campaigns as well. So, they've been in it for the long haul for sure. All right. So, we're going to continue on. I'm going to go ahead and share my screen again in the time we have remaining. Let me go ahead and do that again. Here we go. I'm going to do a quick rundown again because a couple people wanted me to go over this again. Does that look okay, Peter?
Yeah, looks great.
All right, I'm just going to do a quick rundown of this again. Some folks, wanted to know a little bit more about this, because we talked about this briefly when we were doing the Moon Trees Quest, several years ago. But at NASA, we have this program called the NASA Moon Trees Program, and it started years ago in the 1970s with Apollo 14. And basically what happened was in 1971, astronaut Stuart Roosa brought several thousand tree seeds with him in his kit when he circumnavigated the moon in 1971, and they were brought back down to Earth. The seeds were germinated and grown into seedlings, and they were distributed to locations like universities and science centers and places around the United States. Some in South America as well, but mostly in the United States. A lot of them were dedicated at ceremonies during the United States bicentennial in 1976. And they were planted all over, and you can see here all the United States. You can see here, as I mentioned, South America, and there is, a few were planted in Europe as well. These are where the ones were planted in the 1970s from the 1971 Apollo 14 mission. So what happened in 2022, November 2022, we launched the Artemis 1 mission, which was the first potential multiple missions. Artemis 1 was unmanned. It was basically, brought up where the spacecraft was, circumnavigating, the moon, and then brought back down to Earth. And what we did was NASA put on, put a couple of thousand moon tree seeds, moon seeds, tree seeds back on this aircraft, on this spacecraft, and brought them back down to, to continue this legacy of Apollo 14 and the Moon Trees program. And originally they planned the Apollo 14 Moon Trees, to see if if the force of the non-gravity in space, the force, the forces of space would have any any action on or stunting the growth of the trees when they were grown back on Earth, and they didn't. But NASA wanted to do this, to inspire this next generation, inspire the Artemis generation to do this. So we sent basically, the same, tree species of seeds back to, to the moon and back down to Earth. We Douglas fir, loblolly pine, sweet gum, sycamore, and we originally sent the coast redwoods on Apollo 14. But because they have such a limited geographical distribution, we chose their cousin for Artemis 1 in November of 2022. And their cousin is a giant sequoia, which has a larger geographical distribution, not like the other four, but we wanted something close to the coast redwood. So we did the giant sequoia. So we wanted to continue that next, inspiring that generation of the Artemis 1 program. So, here's this objective, inspiring this next generation, bringing more partners, the U.S. Department of Agriculture, bringing the GLOW program, because we did this Moon Trees Quest. As you can see here, this is when Orion, the capsule, splash down. The Moon Tree seeds from Artemis 1 are in that capsule when it splashed down December 2022. And then the seeds were returned from the Kennedy Space Center to the Forest Service in February 23. And then they were x-rayed these seeds for viability, meaning were they able to be grown? And the nurseries across the U.S. germinated the seeds into seedling, monitored by the U.S. Department of Agriculture Forest Service. And then what happened was NASA put out a call to groups around the United States, an application process to universities, science centers, NASA centers, schools, to apply for these around the United States. So I happened to be I was asked by several groups, locally around the East Coast of the United States to, present and give some keynote presentations around the United States, and primarily East Coast. One was up in Reading, Pennsylvania. One was here, of course, at the Wallops Flight Facility at the Visitor Center. And then one was at a Girl Scout camp not too far from where I live in Denton, Maryland. So these are all Artemis 1 moon trees that these groups here applied for, and they were accepted, and they received their moon trees after they were grown by the USDA Forest Service and some of the nurseries. And, they were successfully grown. You can see the one here on the left side. That is a pretty big one that, that's one grew pretty big when they planted it. That was the biggest one that they've gotten so far. But yeah, so you can see here, here's where they were all set. This is actually the first phase of them, and you can see where they were distributed from the sweet gum, which are blue, to the loblolly pine in the dark red, the orange or the sequoia, purple or the Douglas fir coastal, and yellow or Douglas fir south. And you can see here, they had a pretty good distribution across the United States. I believe that there's one phase of the moon trees to go out still. I'm pretty sure there's one final phase to go out yet. So they're the ones that are the final germination going through. But I wanted to bring that to you because, since it's a Trees Around the Globe Student Research campaign, and we had the Moon Trees Quest, which was back in the summer, basically it was July through September of 2023. So we haven't talked about that for a while. But I also wanted to share this video because, as you remember, in this quest, we had folks going out and finding Apollo 14 moon trees and using the Globe Observer Trees tool to measure the height of these Apollo 14 moon trees and to seek out the species that these moon trees were, and then take their tree height observation and submit it to the Globe database through the Globe Observer Trees tool. And Kristen Weaver put this together for one of the Friday. I know it's one of the Friday highlights, but also as part of the Moon Trees Quest. So I want to show you this video. There's no sound involved here, I believe, but I just want to show this to you because this is a feature of the ones that were found as part of this quest. Here you go. So as you can see, those are from all across the United States, and that was really fun to do and see those coming in from all over the United States. All right, so I'm going to show just a couple of these, just a couple of these in the time remaining because we really wanted to focus, this month's webinar on the NISAR talk from Dr. Erika Podest. But I wanted to showcase a couple of these that we've all enjoyed over the last, couple years. These are some of the presentations that some of the students gave as part of our, student presentations with our campaign webinars. And the first one is from Gozo College Rabat Primary School from Globe, Malta. And this is a presentation from Gabriel and Rafaela. So this is the Trees and Us. And I really enjoyed this one because I know Gabrielle was was a little hesitant to present, but he really got excited to present this. But I wanted to show you this one because this is a really good one, and then I have one more I want to show after this, and then just want to highlight the missions that we're going to talk about coming up, and then I'll open up the floor. Then we can talk a little bit about what you've been excited about over the last 7 years, and then we'll talk about what's to come. So here we go.
How about now?
All right, that's a start. If you want to, yep, there we go. Looks good.
Hi, my name is Jessie Marchia. I'm one of the Globe teachers, and
sorry, I meant Jessie. I said Raphael. My fault, Jessie.
I have the Echo School of President, which is Gabriel Grech with me. Okay. Hello. Hi. We're going to be talking. We're from the Gozo College Rabat Primary School. We're going to be talking about Trees and Us. Exploring trees through the phenology campaign and beyond. The Globe, Europe, and Eurasia region.
Our observations of trees. This is our process during the spring phenology, marking our branches, bud bursts, measuring and recording.
This is a short video, which is very interesting.
Greetings from the Gozo College Rabat Primary School. My name is Jomari. My name is Nadia. We came here to show you our big tree. This several times to monitor its growth. It presents this how the tree woke up in spring.
This is the happy school students. We're considered the happy school.
Measuring trees. We learned how to take measurements of all types of trees. This was very interesting as it was our first time, we used the trees tool on the Globe Observer app, and using a measuring tape, we also measured the circumference of the trees.
Here's a short video. Wait a minute. I'm sorry.
Now I can have my freedom again. It turns the country is so and
That's our Globe representative, Miss Ramona Murcia.
While hugging a tree, while measuring trees, we thought that our trees needed a hug. Here is my brother, Raphael, in the middle picture.
Globe STEAM Challenge. We participated in the Globe STEAM Challenge, a national project between Globe Malta and European Direct. Even though we had saplings, unfortunately, our trees didn't grow.
Nature at its best. As you can see, nature has a funny way of getting us to grow trees. This is Miss Jessie's rooftop garden, and a tree, the sand-ripe gum tree, Sidratalar in Maltese, the national tree of Malta, grew by itself in her pots.
Malta and Israel. We also collaborated with an Israeli school, which we each purchased a fig tree and an olive tree during their Tu B'Av holiday. As you will see, we got our figs from the tree. It was delicious. We commemorated 25 years of the Globe program as well.
Sharing with Israel. We shared our recipes and knowledge about the fig tree, and they in turn shared theirs. Spreading the word. The fig tree is Sidratat Maltese. We want everyone to realize that it is important that our planet have trees. Every year, we study a certain tree and make bookmarks for our entire school who share it with their parents. On the back of these bookmarks, there is information such as recipes, medicinal benefits, and fun facts. The importance of trees in the carbon cycle. Here is the carbon cycle. The carbon cycle is when the trees get carbon dioxide and release oxygen. Therefore, trees are good for us, and if we didn't have this, we would become extinct.
Getting the community and parents involved. We got our local community involved by planting trees and shrubs in our local playing field for everyone to enjoy with our village mayor. I would like to thank you for your time, and please
Plant
more trees. And that's Gabriel. I couldn't resist. It's carnival here. And Gabriel and his brother Ralph decided they want to be astronauts.
Okay.
All right, that was one of the presentations, and now I want to share this other one here. Trees in our community using Globe to contribute with primary and secondary data analysis, St. Luke's College, Globe, Argentina. Here we go.
Have you ever wondered how the trees we see every day contribute to the environment? How can increasing knowledge about tree species that surround us help us protect an ecosystem?
We are students from St. Luke's College HSM in Argentina, and for the past 2 years have been researching the trees in our area. concerned about the removal of trees and planting of foreign species. Our objective was to increase knowledge about the trees in our community. We came up with 4 important questions. Which species grow in our neighborhood? Which is the frequency of species? Which is the frequency of height and circumference of these trees? And which is the sample's total carbon capture?
This project started in April 2023 and continued until October 2024. This report is a continuation of our previous studies in the area. The research was done in a private organization called Ara Santa Maria in Loma Verde, Escobar, Buenos Aires, Argentina.
The climate in the area is temperate and humid, with annual averages of 17.2 degrees and 1,104 millimeters of rain. Originally, this area was a grassland, but in the last 20 years, it has developed into a private urbanization. Actual land cover could be considered MUC 821, parks and athletic field.
Through our participation in both LAC tree campaigns, we trained ourselves in globe tree protocols and used them as a way to collect primary data. We analyzed tree height, tree circumference, and species frequency. And this past year, we included the carbon cycle protocol in order to collect carbon capture data.
Our process included going out into the field, collecting data, using the globe tree and carbon capture protocols, and having each individual student upload their data to the Globe app and into an individual Excel sheet. After this, a designated team of students would upload the data into a joint database, which we used for our analysis.
Through our previous research experience, we came into contact with Globe protocols and databases and decided they were going to be the key in this investigation. Thus, we came up with the following research questions. 1. How could obtaining primary data for Globe databases contribute to increasing knowledge about the trees in our community? 2. How could Globe databases help monitor our trees over the years? Specifically, how could Globe databases contribute to deciding future actions, and how we could use Globe visualization systems in order to compare them with trees from other regions?
We sampled 608 specimens, identified 468, and determined 41 species, compared to last year's 25, belonging to 27 families. By analyzing the data we had collected, we determined that the most frequent species is Fraxinus pennsylvanica marshall. Tree heights range between 5 and 246 meters, and tree circumference between 10 and 350 centimeters. Most species are exotic and deciduous, and native species represent 8% of total carbon capture.
One of the most important parts of collecting primary data was the creation of a tree catalog for our community. Senior 4 2024 students created a catalog detailing every species registered and its characteristics. This allowed us to not only become aware of the nature that surrounds us, but also of how our choices can affect the ecosystem. We hope that in the future, when a neighbor wants to plant a tree, they can refer to our catalog and find the option that is best for them and the environment. Through our research, we found an area in the neighborhood that we labeled the Talar area. Talas are native trees, so they add significant value to the ecosystem. Through Google Earth satellite images, we were able to identify that the tree pre-existed the urbanization in the area. Because of their value and antiquity, we consider it of key importance to preserve them.
Through our research, and particularly the complications through it, we realized how easy it is to upload a tree to Globe twice, as coordinates are not always exact. So as a solution, we designed a tree marker prototype made out of recycled bottles to let other Globe scientists know that the specific individual has already been registered. After uploading all of our samples to the Globe page, we wondered if there were any other Globe sites that we could do a comparative study with. We found 2 sites with similar amounts of biometric measurements, Globe V School in Croatia and Colegio Montessori de Cartagena in Colombia. We downloaded their data from Globe ADA and compared tree height, circumference, and species frequency with our own data. This experience allowed us to see just how useful Globe data and Globe ADA can be in interregional comparisons.
Our research allowed us to become aware of the impact trees have on the environment and how important it is to consider things beyond landscaping in private urbanizations. Collecting primary data allowed us to enrich Globe databases and create our own catalog, which we hope will be a useful tool for future decisions. Our data and Globe data and tools also helped us compare entirely different regions and understand the importance of recording and categorizing our surroundings to further understand the world we live in.
All right. As you know, we can't go through every student presentation that we've done the last 7 years, and there's a lot that we could have covered. But I also wanted to do a little disclaimer. If you go to our campaign webinar page, you will see that most of the webinars, almost all of them, are missing right now. They are there, but they did the upgrade to the Globe website several weeks ago. The DIS team is still working to recover all the webinar links. It's just a matter of them going back and restoring them. There's an issue with that, with them and those on a couple other Globe websites. So I will send out a message when they are all restored. I apologize for that, but it's out of my hands. It's the DIS team that needs to fix that. It's on the back end. So that will be fixed as soon as they can get to it. They're running through a lot of issues now. So I'll let you know. Just wanted to highlight a lot of these missions that we've been talking about over the last 7 years. And they range from the GPM mission, the Global Precipitation Measurement Mission, ISAT-2, the SMAP mission, which Erika mentioned multiple times today, down through the Landsat series of missions. I just have, this is an image of the Landsat 9, but we've talked about multiple Landsat missions. The GRACE mission, this is a GRACE continuity mission. And then we have some of the other GRACE missions as well. We talked about JEDI on the International Space Station and the NISAR mission, which we heard a lot about today from Dr. Erika Podest. So these are some of the missions that we really focus on. There's other ones that I didn't include here that we've had over the last few years, like the SWAT mission, EcoStress, PACE we've talked about a little bit, some of the other ones like that as well. So I know we've talked about, there was one, oh, what was that? Had the X in it. I can't remember the name of it. Maybe Peter remembers that one. It might have been a JPL, it was an airborne mission. Sorry, I'm drawing a blank.
Oh, Delta X?
Delta X, yes. Sorry. Yep, Delta X. Yep, Delta X mission. So yeah, lots of missions that we've covered over the years, but I put some of the ones here. And so with that said, I went and threw this together quickly, and it's a mosaic of all the shareables we've had over the last 7 years. So this is 85 shareables that have gone to create this mosaic of where we're coming next month. And we're going to be starting year 8 of the Trees Around the Globe Student Research Campaign next month. So October begins year 8 of the campaign. So that is great news. So we will be getting year 8 of the campaign, and you can see a lot of those missions are around here. But yeah, so this mosaic was created, and you can see 8 is dangling right in the middle there. So we moved 7 off to the side. So we have this stylized tree here with 8 in the middle. But yeah, so this was created using all 85 shareables for the campaign so far. So now what I want to do, since, year 8 will be starting October of this year, I'm going to stop sharing, and in, say, 5 or 10 minutes or so, I just want anybody to, put in the chat or, unmute themselves and just share anything that they'd like to say about, the campaign, or anything, exciting that they've learned in the last 7 years, or anything they want to say about it, things that they thought were exciting, things they love, things they hated, things they want to see more of, anything you'd like to say. So I'm going to stop sharing and come back to the main room.
No, Brian, I will go first, although I'm going to admit to being partial. I think for me, 7 years, that is pretty much unheard of in the Globe, program. Campaigns don't tend to last that long.
Yeah.
And the fact that we were able to keep that momentum going for so long just is like a testament to the hard work that we do. And then seeing the same people join month in and month out, like Anna, John, and others, it makes me feel really good knowing that we're still doing things that keeping people interested and that they care about as well.
Agreed. And I remember when we did, and this isn't this campaign, but when we did the SMAP campaign, and we ran it for, I think, 1 year, like back in like 2014, 2015, I think it was. and then we transitioned it to the ENSO campaign. I remember Dixon Butler saying, you know, why are we stopping this after 1 year? Why is it going to another campaign? A campaign needs to run longer, at least 3 years. So, and I know that, you know, talking to Dixon, you know, every time he hears, like, he asked me, he said, how long is this campaign going, the trees campaign? I was like, we're in 6 years, we're in 7 years. He's like, that's the way it should be, you know? So I always like to hear that, you know, Dixon, you know, being the former chief scientist for Globe and, you know, been around NASA for a long time. So it's always good to hear Dixon's viewpoint, here that the campaign's, yeah, running that long. And so, yeah, and that, and you know, Mission Mosquito, Globe Mission Mosquito's been around as long as we've been. So it's great to see these campaigns, you know, doing this, you know, staying here this long. And I'm glad we have the momentum, because, you know, the trees are always out there and we always need to study them. They're such a huge part of our planet.
Mm-hmm. We have a couple comments from our colleague from Croatia. Amazing campaign.
Awesome.
Sabrina, she says, your campaign gives us a lot of inspiration and motivations to study trees in our region and to make our students aware of the importance of trees. So thank you very much. And we go on and study trees. And then, of course, Anna, she agrees. She said, yes, a lot of inspiration. And I think for us, the same, we get our inspiration from the folks who join us and you know, keep us on our toes and keep us interested and always giving us new ideas to come up with at these webinars.
And it's so great to see, you know, like trees within LAC. You know, we had the group in Ireland, Trees Across Ireland. You know, and I know for a brief instance there, for like a year or two, there was the Trees Across Israel. You know, there was a whole bunch of like groups that were great, you know, great big spin-offs of this campaign, which was great. And it was great to see that we could provide at least some type of inspiration for those groups. And I know the trees, you know, within LAC just, you know, really blossomed and got huge, and, you know, was so great to see, you know, the big presentations, and, you know, and I know they became part of like a larger groups, you know, with Larissa and, you know, Unitar fellows and everything. So it was great to see. That's great to see how big it became and how much participation they've got from across the entire Latin American and Caribbean region.
Yeah, but trees are everywhere, and it's nice that people are making that connection, and we're helping to make that connection for younger generations, the importance of trees in their area and how it has a global impact to the rest of the world. And I think that's the beauty of the GLOBE program. John also has a comment. He says, this is perfect, in capital letters. This is a perfect example of how students that are focused on environmental fieldwork and computers, coding, and technology can come together. I could not agree with you more, John.
Exactly. And I have an example with John is that, you know, John, you know, I've been at John's location at Palmyra Cove multiple times in New Jersey. And the first time we went there, I was working with some students that came into his location, and we took some tree height observations, you know, next to the river where John's located, and then came back the following year. And I'm glad we documented those tree heights, because those trees were gone. I believe, John, correct me if I'm wrong, I believe, but those were taken away by like the Army Corps of Engineers, where they were doing something along the riverbanks. And like we documented those trees, and I was like, I'm glad we documented those and got their tree heights, and we knew they were there, but then when we came back, they were gone. So glad we documented those. Yep, thumbs up. So yeah, thanks, John. All right. So yeah, but yeah, we really appreciate, as a campaign team, of everybody being here, especially those who come to every webinar. And I know we hold a lot of you for longer than we say we're going to hold you, because we always have so much content, you know, to get through. And if I would have, you know, kept everything that I wanted to show today, it could have been like 3 hours, but some of it will hold on for the October webinar. So yeah, so we haven't decided a date on the October webinar. We're probably going to make it a little later on in October, but we'll let you know when the date's going to be, because we have some uncertainties and everything happening right now, going on, right now with, in the United States and NASA and all that stuff going on. But we are definitely going to have a webinar in October, but probably towards the middle to end of October. So we will let you know, and I'll also let you know, as I mentioned, with the webinar, with the webinar recordings when that's up there. But when I get this webinar recording, what I did, you may have noticed also on the webinar page that there is a recording there for the August webinar. What I did was I took a screenshot of, I have the webinar shareable on there. I have a screenshot of the webinar shareable, which and then if you click on that, it will take you directly into YouTube where you can watch the recording. That's different from what it usually is, but that's a good way to, just a temporary fix, so you can watch that. And if it's not fixed by the time I get this recording, which I'm assuming it won't be, I'm going to do the same thing so you can watch this recording, because I got emails from several people today and yesterday saying that they wouldn't be able to make this webinar today, and they want to watch the recording soon thereafter. I'm going to do the same thing. I'm going to put the shareable up under the recordings, and then I'm going to put a direct link to the YouTube. So if you click, you'll see it when you scroll over. It'll be an active link over the image, and then it'll take you directly to the YouTube recording. So it's a little different. Before, you could watch it in the webinar, on the webinar page, or you could watch it on YouTube. But that's what needs to be fixed in the Globe website that the DIS team is working on now. So like I said, I apologize for that, but it's out of our hands. It's on the back end in the coding that we have nothing to do with. So that just has to be done on the DIS team's end. So all right. Anything else from anyone? If not, we will see you in October for the beginning of year 8 of the campaign. Thank you, everyone, and stay tuned, and see you all soon.